try to adjust it now. Okay, let me see. Is it okay? Just few minutes, not much, very little time. Just adjustment only. Is full board visible? Everything visible? I put the mic on, just a minute. If full board visible, I will go for explanation. If the full board is visible, mic I put. Right side adjustment, I think there is no place. Right side adjustment is not possible for me. It is correctly set now. What is the problem? It is correctly visible, everything. I think everything okay. If I move further, left will go. It will zoom out. I think okay, I can name the points once again. 1 minute. I will name the right side and slightly move the point. Okay. D is here. Okay. D. D is here. D. I will push it D here. I will make D here now. Okay, now. If I move further, problem. If I further move, okay, then 1 minute now. If I further move here, there will be a problem because the orientation I made now is perfectly covering the board. 1 minute. I'll check here. Okay, left side slightly I can come this side. Okay, okay. 1 minute. I slightly left this side, little this side. Okay, no problem. Now, this is C. This is C. This is C. Yeah. This is C. You can slightly move now. See? This is C. Okay, I moved every point this side. I think now I can manage. Because once I set here now, if I further zoom, I may lose control. I may lose control of that one. Because with great difficulty, I correctly manage the board. Okay, 1 minute. Slightly I can move now this side. Okay, okay. Okay, now okay. See. Okay, now. Okay, slightly this side. It's playing with me. Tighten this one. Yes. Slightly lift upwards. so that slight upward lift. That 0.36 visible, bottom mode on 0.36 is there. That is visible. That 0.36 should be visible. And the left side bottom number. Okay. Now, is it okay? Okay now? Okay. I start. See, I want little space to explain something here. I will manage it here. 1 minute, don't worry. Colors also required. 1 minute. This color I will use for road placing. Don't worry. Red color is data. Red data. My kind. Because this is what I am doing is I am explaining I told real meaning of ILD and other things. Then I will go to other part. If I need one more class, no problem. Suppose I require one more class, nothing to worry. Okay, now I will first, these sketches are there. This sketch I will remove and then I will go there so that some explanations are there. I will draw the sketch once again here. Don't worry about these sketches. These sketches, don't worry now. Okay. I will tell you first, see, you know ILD, how to draw ILD, yes or no? Now you know how to draw ILD and using ILD, how to find the quantities. Any required quantities, correct? Now, correctly understand what is the meaning of ILD. I told definition. ILD is drawn for what? VA, VB, that is support reactions. Support reaction will create shear for the beam, and for supporting beam, it will create axial compression. Or you can tell it will create section force. Section force will give stresses. So you can call stress function. Same way, shear force bending moment will also, shear force will give shear stresses, bending moment will give bending stresses. So your reaction, shear force or bending moment, all of them finally results in what? Some type of stresses for the member cross section. That's why simple language, instead of telling ILD for vertical reaction, ILD for shear force, ILD for bending moment, general language, you can tell ILD for any stress function. See, ILD for any stress function. Any stress function. For example, say, for example, Q, general Q. This Q can be what? It can be reactions. It can be reactions, or it can be support reactions, or shear force or BM anywhere. This is stress function. So ILD for any stress function is, I defined already. If you want, you write once again. Graphical representation of variation of that stress function, that is ILD for any stress function. Once you decide, suppose you tell ILD for shear force, it is graphical representation of variation of shear force. Shear force at a particular point, say P. So if you tell ILD for shear force at P means, it is a graphical representation of variation of shear force at P when unit load is moving along the member. So general definition, ILD for any stress function is a graphical representation of variation of that stress function when unit load is moving along the member. Clear? That is the basic definition of impedance line diagram. Clear now? Basic definition clear? Okay, now further, then I told you what is ILD ordinate means. This is very important. So many people, they get confusion. See, for example, see, suppose imagine I draw one ILD. See, suppose this is a point P here, P1, one more point P2. P1 value is 1.6, P2 value is 1.2. This is ILD for BM at P1. Just for understanding. Okay, tell me. What 1.6 gives you? 1.6 will tell you what? This will tell you what? Bending moment at P1 equal to 1.6 kilonewton meter, etc. when unit load is at P1. When unit load is at P1. Same way, what 1.2 will give you? 1.2 will give you bending moment at which point? Tell me. Here it is bending moment at P1. What is 1.2? 1.2 will give you bending moment at which point? What? 1.2 will give you bending moment at which point? No, not P2. That is a mistake people are making. How? Once I draw ILD for BM for P1, this is a variation of BM at P1. How P2? 1.2 is also bending moment at P1 when unit load is at which point? When unit load is at which point? ILD is drawn for P1. So, these all ordinate will give you how much is the bending moment at P1 when unit load is placed there. So, ILD is drawn for P1. So, 1.6 will give you bending moment at P1 equal to 1.6 when unit load is placed at P1. Same way. What 1.2 will tell? 1.2 will tell you bending moment at which point? Bending moment at P1 only when unit load is placed at which point? When unit load is placed at which point? Unit load is placed at which point? When a unit load comes which point? No, 1.6 the BM here when unit load is here. 1.2 is the BM here only when unit load is at which point? Tell me. P1. Again P1. What is this one? So, this 1.2 will tell you bending moment at P1 equal to 1.2 if unit load is placed at what? Unit load is placed at P2. Tell what this 0 will tell you. 0 will tell you bending moment at which point? Tell me. This 0 will tell you bending moment where? At bending moment at which point? This 0 will tell you. Suppose this point is A, this point is B. At B, ordinate is 0. What that 0 will tell? 0 will tell you bending moment at P1 equal to 0 when unit load is placed where? Tell me. At B. Same, this 0 will tell you bending moment at P1 is how much? 0 when unit load is placed at A. So, clear now? I will make it clear fully. Today I decided if one class wasted, no problem. When you learn something, learn perfectly. Or that's why I told basic definition. See, now I will write what is the basic definition of ILD ordinate. Okay, see now. Now I will tell. This I used to tell little fast earlier. Have you written? I will tell once again little medium speed. Then I will write on the board. See. What is the meaning of ILD ordinate measured at any point? See, some ILD ordinate will come. Can you measure? What is the meaning of that ILD ordinate? So, general meaning. See, when you draw ILD, you draw ILD for a stress function. Which one? Any one. It can be VA, it can be VB, it can be shear force somewhere, bending moment somewhere. So, once you draw the ILD for bending moment for something, for a particular stress function, then see, ILD ordinate, I will tell first fast here. First fast I will tell. If it is clear, I won't write. ILD ordinate measured at any point will give the value of stress function for which ILD is drawn when unit load is placed at the point where ILD ordinate is measured. Clear? ILD ordinate measured at any point will give the value of stress function for which ILD is drawn when an unit load is placed at the point where ILD ordinate is measured. Or I will write here, see, ILD ordinate measured at any point, measured at any point, like I told you so many values, any point will give value of stress function, value of stress function for which ILD is drawn. So many people, they got confusion here. ILD is drawn when unit load is placed at the point where ILD ordinate is measured or found out or observed, anything measured. I told ILD ordinate measured at any point will give a value of stress function for which ILD is drawn when unit load is placed at the point where ILD ordinate is measured. 100% not by hearted. It naturally comes to me. I don't have to remember ILD ordinate. Why? When I tell something, I know what I am telling. When I tell something, I know what I am telling. For just a joke for you. Someone asked me earlier, I don't want to tell who all. Sir, how you tell so confidently, etc., why there is no technical mistake or confusion? I tell a simple answer to him. If I tell the answer, it may hurt you because he had confusion. Maybe a teaching person, high level. He was a high level person. I told him, no sir, from you, it won't be hurting. I told, when I tell something, I know what I am telling. That indirectly means when he tells something, he does not know what it tells. He told, okay sir, agreed. He told, agreed, correct. He told, correct, sportively. I told, when I tell something, I know what I am telling. I know it, what I am telling. Clear? Anywhere, not only structure engineering, anywhere, if you talk something, if you know what you are talking, then there is no confusion. Clear? Now, see, anywhere you measure ILD ordinate, where you measure ILD ordinate, what should be there? At the point where ILD ordinate is measured, tell me, what is considered? At that point, what is there? Wherever you consider ILD ordinate, at that point, what is there? Tell me. Wherever you consider ILD ordinate, at that point, what is there? Tell me. Wherever you consider ordinate, maybe you may consider ordinate here, ordinate here, ordinate here. This I kept pending actually later. There is unit load. But that ordinate will not give the value at that point. It will give the value of the stress function for which ILD is drawn. Or for that matter, see, this is ILD for VA. Okay, 1 minute now. I will tell you, I will complete it now, B. I will tell you later how I completed. It will come like this. Don't worry. I will tell you how it comes later. It will come this way. Okay, see. It will come this way. Plus here, same line. See, this should be same line. Okay. Minus here. Okay, now. See, you can have an ordinate here, ordinate here, ordinate here, ordinate here, ordinate here. See now. This ordinate gives VA when unit load is at C. This ordinate will give VA when unit load is somewhere here. This ordinate will give VA when unit load is at A. This ordinate will give VA when unit load is placed here. This ordinate 0 will tell VA when unit load is at B. Some ordinate here will give VA when unit load is here. This ordinate will give VA, you should not see here, VA when unit load is here. So, make a last note. Each and every ordinate will be equal to what? Tell me. Each and every ordinate. Once I draw ILD for VA, then each and every ordinate will be equal to what? Once you draw ILD for VA, tell the answer. You write there. If I draw ILD for VA, then each and every ordinate will be equal to what? Tell me. Any ordinate, wherever you consider ordinate, equal to. Wherever you consider ordinate, that ordinate equal to what? First. I wasted so much time telling so many points. Whichever ordinate you consider, once you draw ILD for VA, any ordinate equal to what? You don't answer. I will stop the class. Then. After telling this much, if you don't answer, class should be stopped. Every ordinate you measure, whether you here. Tell me what? Any ordinate, anywhere you measure ordinate. No, I told you very clearly. If I draw ILD for VA, then tell the answer. If I draw ILD for VA, don't tell general definition. I told ILD for VA. Each and every ordinate will give the value of what? Don't tell stress function now. VA. Tell me, here. Anywhere, but remember, where is the unit load? Tell me, where is the unit load? Tell me, where is the unit load? Where is unit load? Unit load where? Value of, see, every ordinate will give VA when unit load is where? When unit load at A, na? If unit load is at A, what is that? Each and every ordinate will give the value of VA. See, this value, everything. Unit load is at that point where you considered ILD ordinate. If I consider ILD ordinate here, it is equal to VA when unit load is here. If I take ILD ordinate here, this ordinate equal to VA when unit load is here. Clear now? So once you draw ILD, you write that one. Each and every ordinate will be equal to that stress function for which ILD is drawn. Due to unit load where you measure the ordinate, at that point unit load is placed. Clear? Okay. Now, to make further clear, I decided today, once for all settlement, I will give a practical example. Doubt will not come to you. See, for example, remember, this is a place where this is a person A, person B, one more person C, one person D, one person E. Different persons are there. Okay, now, imagine everybody are getting payment. Remember now, actually A is equivalent to a support. See, here, imagine A and B are support, others are random point, no support. Now see, to understand, everybody, see, has got some box where people are going to donate, some donation. See, all these people are going for donation. See, there's a VA here, there's a VB here, later. Donations for some reason, money, some reason required. See, now, A is a person, if he gets money, he will use the full money. See, suppose a unit load is placed here, full reaction will come to A. If I put 10 here, VA equal 10. If I put 100 here, VA equal to 100. If I put 1 here, VA equal to 1. When you apply unit load 1 here, if VA equal to 1 means 100% to A. Clear? A and B are special people, supported people. They will take the load, anything comes there, they will take directly, full. Clear? Okay. Now, the CDER, they are people, they don't what? They don't keep the money. They will give either to A or to B. See, A and B are the people who are in need of funds. There are people here who are collecting funds, but they don't want money. They will collect, no doubt. See, one person is collecting in some area, majestic area. One person somewhere else, some other crowded place there. These people are somewhere else, some other area, they are collecting. Now, C is closer to A, E is closer to B, D is the midpoint. Imagine, midpoint. What C will do is, what money he gets, 75% he will transfer to A, and remaining 25% he will give to B. Clear now? If he gets 100 rupees, 75 rupees he will give to A because he is closer to A. He is a person who is fond of what? A. Whereas B, he will give. He does not want any money. See, if you apply a load somewhere here, tell me, is any reaction is there? If you apply a load somewhere in the span, load has to go to support. Yes or no? Load has to go to support. Tell me yes or no? Load has to be transferred to support. Answer. Finally, load will go to support. Tell me yes or no? Not answering. Wherever you apply the load, finally load should be transferred to support. I think yes, you already told, I think. Okay, yes. Therefore, A is what? If he gets something, he will keep full. If B gets something, he will keep full. If C gets something, he will transfer 75% to A, 25% to B. D is impartial. What he will do is, he will transfer 50% here, 50% here. Person E, he is more closer to B. For example, he will transfer, actually remember, E is furthermore closer. Then how much close C is to A, this person E is furthermore close. He will transfer 80% to B and 20% to A. So now if I draw ILD, see, I will draw ILD for what? ILD for VA. So I will tell equivalent to VA, or ILD for what? Money obtained to A. Tell the answer. If somebody comes and pays A, tell the answer. How much money A will get? Tell. 1 means 100%. Full means 1 means, see, if I tell 1 year means full. If someone gives 1, how much? One bundle of note, 1 bundle of some note. Tell me, how much money A will get? How much money A will get? Full. A will get full 1. B later. No, tell me. Don't worry about B. We want ILD for VA. When you draw ILD for VA, you see only VA. Okay, now, if a person comes here, he gives 1 bundle. Bundle has got, imagine, 1 lakh rupees. Here, 1 lakh rupees is there. Full 1 lakh here. 1 lakh rupees. Yes, tell me. How much money A will get? Linear. How much money A will get? See, if a one bundle containing 1 lakh is there, this person receives. Of that money, how much money he will give to A? How much? How much money he will give to A? If he gets 1 lakh rupees. This money matter, I told already. See, 75% here, 25% here. Of 1 lakh received by this person, what money will come to A? 75,000. 75% means how much percentage? How much percentage? 75%. Tell decimal form. 75%. Tell in decimal form. Decimal form. Tell it. 75% decimal form. Decimal form. 0.75. 0.75 goes to A. How much goes to B? Tell me. How much goes to B? 0.75 to A. How much goes to B? How much goes to B? No, wrong. If somebody is asking me how much goes to B, if he is taking class, I will tell him correctly, sir, you are drawing ILD for VA. Yes. Then why are you talking about VB? These are all the values which A is going to get. What money comes here, full will come here. If a money comes here, A will get 75%. B will not come. I will tell him clearly. Why you are talking about B? I don't answer the question. Your question, I don't answer. Irrelevant. How much B gets, let us consider when ILD for VB is drawn. Clear now? How you don't answer for B. How much money B is getting, you answer when you draw ILD for VB. Clear? This is ILD for VA. All these amounts are what? Any amount here is what? Money. All these values are what? Money obtained by whom? When I draw ILD for VA, every ordinate is money obtained by whom? Money obtained by. ILD for VA means every ordinate is money obtained by A. Okay. Now, suppose some unit load comes here. Same 1 lakh rupees, one bundle of old 1,000 rupees. Okay. Now, tell me, how much share VA will come? How much VA? If you apply 1 lakh, full 1 lakh. If you apply 1 lakh here, 75,000. If you apply 1 lakh here, how much? 50,000 or ordinate is 0.5. Okay, tell me, here, if a 1 lakh rupees bundle, one bundle of 1 lakh rupees, tell what money A will get. Tell the answer. What money A will get? What money A will get? Zero, no? Ayyo, why zero? What is this? I told E is closer to B. C, D, E are collecting money finally to give it to A and B only. But this person is more closer here. He gives major share here. He gives equal. This person gives more B. How much A is getting? Zero. How zero? How zero? I wrote the number there. How you told zero first of all? Then again class has to be closed. You put a zero. 20%. That is 20,000 rupees. Correct? Then see 0.2 here. And if 1 lakh rupees comes to B, then how much money A will get? If somebody gives 1 lakh rupees to B, how much A will get? B will not give. B will keep himself. He will tell, this is my money, I am not giving. Zero. This is ILD for VA. Same way, shall I draw ILD for VB? ILD for VB. See, if the money given to A is there, now see only VB. If a bundle comes to A, he will not give anything to B. Zero. If a money comes here, whatever money, 75% A will keep. Sorry, he will give to A. 25% he will give to B. 0.25. This person will give 50%. 0.5. This person will give you 80%. And finally, if the money comes here, he will take the full money, ILD for VB. So, these are all what? These ordinates are all, or these ordinates are what? How much money A is getting when unit load means that bundle note, one bundle, when that bundle of note moves from A to B. This is how much money B will get when the bundle of unit note, one bundle moves from place to place. The bundle of one bundle note is, one unit is what? Unit load. So, ILD ordinate measured at any point will give the value of stress function for which ILD is drawn when unit load is placed at the point where ILD ordinate is measured. And lastly, conclusion. Once you draw ILD for something, anything, then each and every ordinate will give that one. That means what? If you draw ILD for Q randomly, ILD for Q, what is Q? Reaction or shear force or bending moment. If you draw ILD for Q, then in the ILD, each and every ordinate will give the value of Q due to unit load placed where ordinate is measured. I will stop. Fully clear? nearly half an hour. Full clear or not? Okay. Now, I decided to make a complete clear understanding for everybody, those who are watching this class, to thoroughly understand the meaning of ILD. I decided one class extra is no problem. Okay. Okay. Anyway, this week, okay, now see, I will remove the sketch. I will put full. Now I will do one thing. Once again I will put now. Space problem is there, I will manage. Now see. Now for example, make a note. Consider what I am telling, right? Consider a simply supported beam. A, B are the supports. Between support, span is 10 meter. 10 meter because it is easy for me to calculate. Okay. Now, let there be left side overhang of 4 meter, right side overhang of 3 meter. Clear? This is the beam. Clear or not? You write a statement. You consider a beam which is supported between two supports A and B 10 meter apart, and left side there is a overhang of 4 meter, right side overhang of 3 meter. Now one note, in this class ILD for stress function for simply supported beam completely over, but simply supported beam with overhang is still pending. Yes or no? Is still pending. Yes or no? Still pending. Is still pending. Tell me yes or no. ILD for pending. But when I go to ILD for beam with overhang, right here. But problem is, when I go for ILD for beams with overhang, before that you should thoroughly understand the meaning of ILD and what the ordinate represents. So your conclusion, draw ILD for VA, everything is VA. Draw ILD for VB, every ordinate is VB. Draw ILD for BM, every ordinate is BM. Draw ILD for shear post, every ordinate is shear post. Where, due to what? Where you measure the ordinate, there you place unit load. Clear? Now I will not tell again and again. Clear or not? Now I will not repeat. Full clear? I will not explain once again now. Clear? Okay, now further. Therefore, first you should understand the meaning of ILD, then overhanging beam becomes easy for me. But one thing, to understand thoroughly, I want example of the beam with overhang. Then somebody will ask, you have not yet covered the overhang, how you can draw ILD for overhang? How you can draw ILD for overhang now without explaining? My answer, it is going to be covered little later. I am only covering. Today, I will draw the ILD when overhang is there. You have to believe me. Agreed? You have to believe me. After I complete the ILD for overhang, then you come back and see, oh, correct. Now fully clear. Once I complete the ILD for overhang, then you come back to this one and observe. You should tell, oh, fully clear. So therefore, now you have to believe. Agreed. Okay, now, see. Our beam, you write here, there is a beam. See, I will put here now. AB, between of supports are AB, span 10 meter. There is a left overhang of 4 meter, right overhang of 3 meter. Okay. I will call this point as C and D. Now, what I want is, I want ILD for vertical reaction VA, then ILD for VB, then after that one, then one extra point. See, it will not, when I do VA, VB, it will also one extra point. This is A, this is B. Somewhere in between, red color point P. Where is P? At random point, at 3.6 meter from A, I want shear force at P and bending moment at P means I want ILD for VA, ILD for VB, ILD for shear force here, ILD for bending moment here. And I want you to thoroughly understand the real concept of ILD now. For that, first do one thing. You consider ILD for, first consider ILD for VA and ILD for VB. When you consider ILD for, but remember, only one at a time. When you consider ILD for VA and VB, tell me, will that point P will come? Will that point P will come? When I consider ILD for VA or VB, will that point P will come? Will that point P will come? If I draw ILD for, see the beam there, VA or VB, that point P will come. No, will that point P will come into picture? Or do you have to consider that point P? No. Therefore, see, when I draw ILD for VA, I am not marking P. When I want ILD for VB also, I am not marking P. So write a note here. Now, right here. Now consider P. Now consider P. That is what? That is what? P means ILD. Now consider what? Now consider ILD for bending moment and shear force at P. At P. So now P will come. See, point P is here. Where from here 3.6, from there 6.4. Correct? Okay, now I will draw ILD. 1 minute. If the overhang is not there, tell me, if the overhang is not there, is ILD for VA 0 to 1, ILD for VB 2.304. Remember, 3.6 into 6.4 divided by 10. I will not explain to you. You know it. This is called A. This is called B. AB by L here. I won't write AB by L. You should write it. Okay. If you want, not required, leave it. Why should I write? You know it already. This is equal to AB by L. Okay, everybody. And this is equal to A by L. This is equal to B by L. Is this, see, 0.36 here, minus sign. This is plus sign. This is the point what? This is A, this is C, this is B, this is D, this is the point P. Is this ILD clear if overhangs are not there? Tell me. Is this ILD clear if overhangs are not there? Is this ILD, no. Is this ILD drawn so far is clear if overhangs are not there? Clear. Now I want ILD for VA, VB and BMSF when the unit load is placed not only between, see, these ILD you can use when unit load is anywhere between A and B. You cannot use this one when the load is this side. So what I will do is, now I will draw ILD including overhang. Nothing to worry, I will explain to you. See what I am doing. I will use dotted line here. Okay. Like dotted line. Time being, don't bother. This ordinate is 1.4. Same line continued. Why I will tell you. Negative. This ordinate is 0.3. Why you don't bother? Oh, space problem. This is 0.3. Now, I will extend here. Plus sign only. This is 1.3. This is 0.3. I will extend here. Never bother what I am doing. Not required for you. This is 0.4. Negative. Then I will extend here. Y means, I will tell you, don't be impatient in my class. I will extend here. Y means, I will tell you, negative sign, and I will extend here. Negative sign. This extension is E-line extension. 0.3. And I will extend here. I will extend here. This is C point. C point plus 0.4. This ordinate I will tell you, this is 0.4. ILD for what? Shear force here as 0.4. Okay, now still not over. I will put the remaining values. You do not bother what I am doing now. You do not bother what I am doing. .56. You never worry what I am doing. You simply believe me today. Simply believe me today. Here. .08. Today, see, rounded values, you simply believe me today. Believe me for rounded values. Rounded values, you believe me. You should tell, I think this person knows the subject, therefore I can believe him for some time. Believe me. Rounded value, you believe me. Do not worry because it will come later. Clear? Clear or not? First tell me. Rounded value, you don't worry. Everything visible? 1 minute, let me check. Everything visible there? No. Everything is visible? Is everything visible? Nothing should be covered. If everything is visible, okay. All visible? What all I marked? Visible. Okay. Now, I will start the real concept of ILD. Start. Okay. Do one thing. Do one thing. Now, I will use blue color or green color for unit load placing. See now. What I want is, I want one by one case now. See, first, this is the beam. Okay, see, 1 minute now. I will do here, everything here. This is the beam. Okay, to understand, I will put double line. This is the beam. Okay, I will put demo here to understand. Don't see that side. This is the support, this is the support. Okay, I will put this way, like hinge support. Okay. This distance is what? 4 meter. This full span is 10 meter. This is 3 meter. This point is A, this point is B, this point is C, this point is D. Okay, now I also want, see, this is sufficient for ILD for VA or VB. First I will do one thing, I will complete VA and VB first. Okay, see, first I want, see, at C, I want to place a unit load. I want to place a unit load at C. See, now, if I place a unit load here at C1, can you find the support reaction? Tell me, by equilibrium, can you find the support reaction? Tell yes or no. After the class, not now. Sigma m about A0. Can you find support reaction? Take moment about A, VA, VB. If you can find means, I won't waste time. I will directly enter support reaction. Okay, you can. Then this reaction VA upward will come 1.4 and this reaction VB will come 0.4 down. Why means you don't bother. It will come down 0.4. You take moment and check it. When you apply the load here, that support is getting lifted. Okay. Now I want to correctly understand the concept. Tell me. Now imagine there is a point P here. Okay, now that P will come. Not this pen is not writing. Okay. There is a point P. Now P will come. Okay. There is a point P here. Red color point. Okay. Where is the red color point? There is a point P here, which is from here to here is 3.6 meter. From here to here is 6.4 meter. It is there. Okay, now, when the unit load is here, I got VA upward 1.4, VB down 0.4. I want what is shear force at P. Tell the answer. I want what is shear force at P. Tell the answer. Shear force at P. Look this side. Down left side, remember, our shear force convention is what? Left up, write down positive. I will not tell each and every day. And our bending moment convention is sagging positive. And reaction sign is what? Reactions VA and VB are upward positive. See, ILD for VA up, ILD for VB up, ILD for BM at P sagging, ILD for shear force at P sagging. Okay, tell the answer. What is the shear force at P? Look this side. Answer. -1. You see this. I will tell in the class. I won't write. Why? Because for this beam, if you want to explain shear force bending moment, I cannot take the class. What I get the answer after the class, you show calculation and get it. Clear now? After the class, you show the calculation and get it. Clear now? Because my purpose is to show you variation of stress function. Okay, start. Shear force at P will come. See, look this side. -1, left side you are seeing. If you see left side, left up is positive. -1 plus 1.4 will come plus 0.4. And bending moment at P will come, see here, -1 into 7.6. Tell the answer. -1 into 7.6 plus 1.4 into 3.6. Answer. Bending moment, fast, don't waste time. -1 into 7.6 plus 1.4 into 3.6. Answer. Don't waste time. -2.56. Okay. This is the answer you are getting. Remember, if the load is in kilonewton, distances are in meter, these are in kilonewton, shear force in kilonewton, BM will be kilonewton meter. If the load is in Newton, distance in millimeter, reactions are in Newton, and what? Shear force will be in Newton, bending moment will be in Newton millimeter. Unit you are not bothered. Okay, now what I will do is, okay, check the answer. So now unit load is at C. Tell me, whether you want VA or VB or shear force at P or BM at P, for each of them you have to go to respective ILD. You write today's class, what I tell, you write everything. If you want VA, you go to respective ILD. Clear? If you want VA, go to ILD for VA. If you want VB, go to ILD for VB. If you want shear force at P, go to ILD for shear force at P. If you want bending moment at P, go to ILD for BM at P. Consider unit ordinate where? Ordinate to be considered is where unit load is there. Tell me, for all this calculation, tell me, where is the unit load? Tell me, where is the unit load? Tell me fast. Where is unit load? For all this one, where ordinate means where unit load. Tell me, where is the unit load? You are wasting lot. Unit load at C. So go to ILD for VA, ILD for VB, ILD for shear force at P, ILD for BM at P. See what is the ordinate at which point? Tell me. What is the ordinate at which point? What is the ordinate at which point? What is the ordinate of ILD at which point? ILD ordinate at which point? At C. Okay, start. This is plus actually. Remember, I told you plus only. Okay. Plus 1.4. Oh, correct. VA over. Suppose I want check VB. Go to ILD for VB. Minus 0.4 because ILD for VB upward direction, but VB is negative down, minus 0.4. If you want to check the shear force here, go to ILD for shear force at which point? ILD for shear force at P, ordinate here. Where is the ordinate? Plus 0.4. See, I will do one thing. Next time, I will do bending moment first. Okay. Plus 0.4. If I want to check bending moment at P, when unit load is here, Go to ILD for bending moment at P and consider the ordinate at C. Oh, minus 2.56. Perfectly tallying? Tell me. Perfectly tallying or not? Tell me. Perfectly tallying? These ordinate I will tell you next time. Perfectly tallying or not? No answer. Is it perfectly tallying? You are not answering nowadays. Yes, okay. Now do one thing. I will change the unit load now. I will place the unit load somewhere here. Unit load here. 1 unit load here. And you will take at a distance of this 4 meter, 2.5 meter from here. I will do one thing now. Before that, I will go to ILD and find that point. I will call AB. I will call the point as E. E. Okay. I will come to the point E here and get the ILD ordinate. Can you get it? Tell me. Can you get it all? Can you get all this ordinate? Tell me yes or no. Can you find all this ordinate? How? Tell me. How to find the ordinate? How to find that ordinate? How to find those ordinate in the ILD? Not beam. One should. How to find those ordinates there? How to find the ordinates means this much time. In the ILD, how to find those ordinates? This much time for answering the question. How to find the ordinate at that point or any point. Once you draw the finish ILD for standard points are over, anywhere you require, find the ordinate using. What is this? This much delay to answer the question. Then really difficult to take the class. Similar triangle. Okay. I will know similar triangle. I will write the answer. You believe me. If it is 0.4, let me turn it to 2.5. Ayyo. Ayyo. This calculator is so horrible. 0.15. This ordinate is 0.15. This ordinate is 1.15. Blue, this color is what? Extraordinate. Corresponding ordinate here is 0.96. And corresponding ordinate here is 0.15. Okay. Stop. Now leave it. Don't worry about the ordinate. Now do one thing. Place unit load here. Now reaction will change. Yes or no? Tell me. Reaction will change. I will take moment about A, find the reaction. Your VA will come. I know the answer. Now VA will come 1.15. VB will come 0.15 down. VA will come 1.15 up. VB will come 0.15 down. And your bending moment. Bending moment at P equal to, tell the answer. Start. Minus 1 into 3.6 plus 1.5. See, when this is 4, this is 2.5, this is 1.5. Tell the answer. Plus 1.15 plus 1.15 into 3.6 minus 1 into bracket 3.6 plus 1.5. Answer. See, 1 into 3.6 plus 1.15 is hogging. Negative bending moment plus 1.15 into 3.6. Answer. This much time to get the answer. If you don't give the answer fast, what I can do? You should write after the class. I will, the moment today's time over, I will stop this example. I will not go up to end. See, if you do this way, I cannot reach the end. That is sure. Tomorrow I do not want this example. If you don't give the answer, I will try up to 5 minutes, 9 o'clock. Then suddenly I will stop. Remaining, you only check. You are losing opportunity of learning more. That means you are losing opportunity of learning more if you don't give the answer. Minus 0.96. Minus 0.96. Tell me what is shear force at P. What is shear force at P? See here. Plus 1.15 minus 1. Answer. Plus 1.15. Look this side. Minus 1. Answer. Plus 0.15. Plus 0.15. Now, check the answer by ILD. What do you have to do? Now go to ILD. Go to ILD. Tell me. When you go to ILD now, you should see ILD ordinate at which point? Tell me. You should see ILD ordinate, load is at E. So you should consider ILD ordinate at which point? Tell me. You should consider ILD ordinate at which point? Again, same problem. To type a name at E. Start. ILD ordinate at E is plus 1.15. Oh, correct. VA, ILD for VA will tell you plus 1.15. If I want to check VB value, go to ILD for VB. It is telling minus 0.15. Oh, correct, down. And if I go for bending moment, it is telling ordinate is minus 0.96. Oh, correct. And if I go to shear force, it is telling minus 0.15, plus 0.15 on the upper side. Oh, correct. Everything is tallying. Yes or no? Fast, tell me. Everything is tallying. Little fast, don't waste time. Everything is tallying. If you answer fast, I can go fast. You are not telling yes or no, nothing, no reply. Even those who come live, so many they come live, they don't comment, they will come and go. Such people I never consider as coming to the class. See, this much, either you are deliberately delaying. What I will do is, I will continue. When my time is over, I will stop the example, remaining for you only. Clear? Okay, now, I will do one thing. I will remove the point E. E is not there now. Next, I will go one thing. See, this all I will remove. Okay. I will place the unit load directly at A, 1. If I place at 1, then VA will come 1. Direct compression. Now, the beam will not bend or shear. Reaction will come 0 here. Then if you apply a beam, if you apply loaded support, that load is transport support. See, BM also will be 0. SF also 0. See here, look that side. Or if you look this side, equal and opposite. So then VA equal to 1, VB equal to 0, BM at P0, shear force at P0. See the ILD? Now your ILD ordinate should be at A. Why? Unit load at A. See here, at A. VA ordinate plus 1, VB ordinate 0, shear force ordinate, bending moment ordinate 0, shear force ordinate 0. Perfectly tallying? Tell me, perfectly tallying or not? Tallying or not? Okay, tell you. Now, that also over. I will remove this one now. Now I will do one thing. I will remove these values. Each time you are writing a sketch, you have to keep on writing sketches one again and again. One more sketch required. See. Now I will place the load, unit load, somewhere here. 1. Where? Somewhere. This is 3.6. I will place at 2 meters from here. Say that point I called E, I will call the point as F. Okay. Now I want answer. Okay, start. Before that, I will go to the point F here. See that point F here, somewhere here, and get the ordinate. This is plus actually, and get the ordinates. I will get the ordinates here. I will get the ordinates here. See, all these are point F, point F, point F, point F. If I get here, the ordinate is 100%, 0.8. This ordinate is 0.2. This ordinate is 1.6. And this ordinate is 0.2. This ordinate is 0.2. Okay. I got the ordinate there. How to get it? Similar triangles. Start. Now, if I place a unit load here, now remember the overhangs are dead. Correct? Overhangs are dead. Why? No load on the overhang. See, if load is acting in the overhang, effect is there inside the beam. But if load is acting in the span, no effect on the overhang. Clear now? In any building, when overhang is there, if the load is in the overhang, effect is there on the inside portion. But if the load is on the inside portion, no effect on the overhang. Even if you calculate, it will become 0. Now, your VA will come 0.8, VB will come 0.2, BM will come 0.8 into 2 plus 1.6. Shear force at F will come, see, at P, shear force will come plus 0.8 minus 1 is minus 0.2. Go to ILD. Now go to ILD and check the ordinate at F. Start. Oh, see, at F, ILD ordinate is VA is 0.8. Oh, correct. VA is 0.8. If you want to check the VB value, go to ILD for VB, check the ordinate. Oh, 0.2, correct. Oh, sorry. It is upward 0.2. I forgot to write. VB is now upward 0.2. Okay, 0.2, correct. If I want to find bending moment at P, go to ILD for BM at P and ordinate at F. How much? 1.6. Oh, correct. See, correct. 1.6. If I want to check shear force at P, go to ILD for shear force at P. Load is at F. See the ordinate at F. Yes, 0.2. Tally. Okay, now I'll do one thing. Now I want next load this side. Unit load this side. I'll take a small break. You should get the answer. Small break here. See, unit load here. I will place unit load at some distance from here. One more sketch you have to write. EFG point at G at a distance of 5 meter. 5 on the center. 4.5 meter from here. I will take unit load. Okay, now you get the VA, you get the VB, you get the bending moment, you get the shear force. I will go to ILD and at that point G, I will get the ordinates here. At the point G, the ordinates are 1.62. The ordinate here is 0.45. Therefore, if I see, now do one thing. Do not see ILD. You tell me what is VA, what is VB, what is the BM, what is the shear force by using basic knowledge. By using basic knowledge in a paper, you write VA, write VB, write BM, write shear force. Once you get these 4 values, you go to ILD for VA, see the ordinate. Go to ILD for VB, see the ordinate. See ILD for shear force at P, see the ordinate. Go to ILD for BM at P, check the ordinate. If tallying, in the comment box, write perfectly tallying. That is, you have to get I won't tell the answer. Your answer is there. In the comment box, you type perfectly tallying. I will come back after 3 minutes and complete when the load is on that portion, right overhang. So that complete idea is clear. Okay, I will take 3-4 minutes time. Oh, so fast if you tell. Okay, then I will do one thing. Last one, I will give. Okay, no problem. Good. Tallying. Okay, so now reaction VA will come 0.45. VB will come 0.55. BM will come, see here, 0.45 into 3.6. 1.6. Shear force will come plus 0.45. Okay, check the answer here. Oh, tallying. See, VA 0.45, ordinate 0.45. VB 0.55, ILD ordinate 0.55. BM 1.6. Oh, 1.62. 1.62. Sorry. 1.62. Shear force 0.45 tally. Okay, now I will go for unit load at exactly B. Then your VA will be 0. VB will be equal to 1. Bending moment shear force will be 0. Why? Load is directly applied to support. That support will take the reaction. Beam will have no bending, no shear force. Therefore, ordinate at B should be 1 only for VB. Everything else, it should be 0. 0, 1, 0, 0. Fully clear? Tell me, fully clear or not? Okay, now, lastly, I will go to unit load somewhere here. Somewhere here, unit load. To make the concept fully clear, those who are serious, they will understand everything now. Somewhere here. Okay. Unit load here, imagine distance from here is 2 meters. Okay. That point is H point. Now I want VB, I want VA, I want VBVA and BMSF now. But I will go one thing, I will go to ILD ordinate at the point H. I will see what is the ordinate. This ordinate is 1 by 3, 0.2. This ordinate is, that ordinate is 2 ಅಂದರೆ 1.2, 1.2 ಅಂದರೆ you not permitted for you, you cannot do this way. 1.2, 0.2, 0.72. This ordinate is, ಇದು 0.2, this is 1.2, this ordinate is 0.72 minus this ordinate negative, that ordinate is 0.2. Okay, now see here, last part. Now your reaction VB will come up by, take moment about this point 1.2. Reaction VA will come down 1.2. Now bending moment here will come minus 0.2 into 3.6 will come minus 0.72. Shear force will come, look this side, minus 0.2. Check the answer. VA ordinate, see, minus 0.2 downwards. VB ordinate, upward, positive, 1.2. Shear force at P ordinate, minus bending moment ordinate, see there, minus 0.72. Shear force ordinate, minus 0.2. Okay. Now lastly, I want unit load somewhere at the right extreme end. This time you should get the answer. I will tell you one thing. VA should come minus 0.3, VB should come, see, your VA should come now, minus 0.3 means down 0.3. Your VB should come plus 1.3, BM at P now should come for this one, last case. BM at P should come, where is the answer? Minus 1.08, shear force at P should come minus 0.3. Okay, do one thing. This is the answer you have to get as per ILD. See, minus 0.3 plus 1.3, then minus 1.08 minus 0.3. Now you place the load there, find the reactions and check the reactions and shear force BM here. Check it. Once you get the answer in the comment box, write got it. Once you get the answer in the comment box, type got it. I will comment, check the logic and close the class. Wait, 10 minutes more. Tomorrow I cover overhanging case. So today, now one thing is guaranteed, correct? At least one thing guaranteed now. Even though I have not explained overhang, some will tell, hey, correct कन्नड़ದಲ್ಲಿ हिंदी सब कुछ ठीक है, पता नहीं, इसको थोड़ा थोड़ा सब्जेक्ट आता है ಕನ್ನಡದಲ್ಲಿ, ಸ್ವಲ್ಪ ಸಬ್ಜೆಕ್ಟ್ ಗೊತ್ತಿವ್ರಿಗೆ ಪರವಾಗಿಲ್ಲ, ಇಂಗ್ಲಿಷ್ ಹೇಳ್ತಿದ್ರೆ at least he knows something. Stop. You tell answer tallying. When I see answer tallying, I will come back and close the class. You should type tallying. And I won't talk to you once again. Tell me, is the ILD concept, meaning of ILD ordinate completely clear how ILD, what is that variation, is the ILD concept, meaning of ILD ordinate. Completely clear by this example, tell me. Completely clear or not by this example? The meaning of ILD and what is the meaning of ILD ordinate, what it indicates to you, completely clear. I told you, ILD ordinate measured at any point will give the value of stress function for which ILD is drawn when heat load is placed at the point where ILD ordinate is measured. 100% not by hearted. Okay, I will close down.